Now let's look at adding filters to our existing data model. This is where the scenario contains more details or the user wants more details. So you have a model and you show the results to marketing, and now they say something like the statistics they want to see are for just male bike buyers. So their campaign is now directed to a specific gender. The scenario has changed, but all we have to do is copy an existing model and add a filter. The filter helps target the model to this specific set of data. And you can see you can just add a filter to an existing model. But what you might want to do is copy an existing model. The steps include copying the model and then adding the filter. The filter does not have to be just one column, and there are options for using or, and for the available comparisons of the different attributes. Of course, an additional thing the user wants is the accuracy of the model. Here, the question will come, how accurate are these models? And there is a tab for that. As well, you can compare two or more models and see how they rank against each other and against what would be a perfect model. The configuration is the first step, and the input for the lift chart includes selecting the predicted value of the model you want to show. The data set used can be model test data, structured test cases, or a completely different set of data. After the configuration is complete, you click on the Lift Chart tab to compare the model chart accuracy with two different things. The bottom line is a random guess, 50%, and the top line is an ideal model, which is 100%. You can see if there is a plateau for the percent of the data versus the percent of the population. The population percentage will show you the score for each model. This example shows the decision tree bike buyer is more accurate than the same model with a filter on males. So now we need to demonstrate the filter and accuracy of data models. First, we're going to launch SQL Server Data Tools, and once the application has come up, we're going to go to the recent project and pick our data mining project. Here we'll go to Solutions Explorer and look at our mining structures for the bike buyer. Over in the mining model, our user has requested the decision tree model to be specific to male and female. So here we can right click the model and create a new mining model. We'll give it a name, designate it as male, and keep the Microsoft decision trees. It'll add an additional column. Here we can right click and go to Set Model Filter. In the Set Model Filter, we'll pick the column gender and we'll say equals M for male and click OK. We can right click that same model, create a new mining model, give it a name, and click OK. Since we copied from it, when we right click to look at the filter, we can change the M to an F and click OK. Of course, in order to see anything related to those, we have to process the whole entire mining structure. Once we start it deploying, we click Run to process it, and then it'll actually process the data. Here, of course, we get a display of the progress as it goes along. As you add mining models and different algorithms, this will take longer and longer to process. So it needs to be noted that selecting your test data set can sometimes influence the processing of this data. Of course, this is not something that's run all the time and is run periodically when it is requested for a prediction. Now that we have these, we'll go to the mining viewer, make sure it's deployed first. Once it's finished deploying, then we'll change it from bike buyer to bike buyer male. Once we get the bike buyer mail up, we'll see probably different data related to this versus the one for all the population. And here, let's change all cases to 1, and then we can see the shading of the Pacific region as being one of the most influential ones to buy. Even Europe seems to be a little bit more popular, and in the mining legend you can see the number of cases, 602, and the probability of 64%. These shadings you can click on to see the different probability. You can actually right click in here and drill through to the different data. So for instance, if we want to see the yearly income that's greater than 122,000, we'll right click, drill through, and get different information associated with that. We can also drill in and out to see the different shadings of this particular data. Now, disabled is the ability to drill through. So probably in the mining structure itself, that is not indicated. So I'm going to go to that DT bike buyers, go to my properties, and you'll see the allow drill through is false. Here I'm going to change that to true, and then I'm going to have to reprocess this model. Once it's finished reprocessing, then I should be able to drill in to that particular data set. But until I change that property, I cannot use the drill through. So you might be asking the question of what the drill through is for. So you find a certain predictability, and the end user wants more data about that particular probability. So by being able to drill through, we'll show an example of this, of that yearly income, we'll be able to see either the mining columns or the model and structure columns. And in this case, you can see a display of that, and towards the right, you'll see those structured values. So for instance, last name wasn't used in the prediction, but you can display it in this set. You can copy all and then paste it into an Excel spreadsheet. The next thing we're going to look at is the mining accuracy. So I'm going to click that tab, and I'm going to pin down our different displays on our right. Here, we need input selection first. I'm going to go ahead and first select the predicted value, and I'm going to take off the different cluster, naive Bayes, and neural network models. And in the lower left, I'm going to tell it to use the mining structure test cases for accuracy. So rather than using the actual data that created it, I'm going to use that set of data set aside to look at the accuracy. Then when I click lift chart, I'm going to get those particular charts. That upper line is the perfect model, and the lower line is the 50-50 model. So you can see that our bike buyer with the whole population actually has more probability than our individual males. And you can see the different scores for that. The male and female seem to score the same, but the female has a higher target probability and a lower prediction. And you can see our actual bike buyer with the whole population has the best score for any of the models. So now that we have a model, additional algorithms, filters, and accuracy run, now we can actually use new data to use a model to predict. So you've created, modeled, and tested the data, and the viewers enabled you to examine the results. Now you're ready to use the model to predict customers for a mail campaign. The predict function will let you look at the customers most likely to produce a bike. The new data should have similar demographics data, but does not have to. The same column names can be used, or different ones can be used. We can add a calculated column in the data source view if necessary for values or columns not available. Running the model to predict the outcomes will be related to this new data and not the test, training, or validation data. Of course, you want to analyze the results, and this is very brief, so you have the option to copy one row, selected rows, or all rows to the clipboard, or an even better option is you can place it in a table which can be added to the current data source view. The new data we might want to take a look at first. In this example, we'll be using the prospective buyer table in the AdventureWorks Data Warehouse 2014 database. This is a table of customers that the marketing department want to see if they are likely to buy a product, and in this case, it's a bike. And also, we have the attributes which make them most likely to buy a bike. The demographics are similar to the model for a decision tree with gender, children, total and at home, education, occupation, etc. The age will have to be calculated from the date of birth. The unknown column is created in this table to relate the bike buyer predicted column from our model. The data source view was used to add the prospective buyer table to the project. The Select Case Table button on our Mining Prediction tab is used to select the table from the Predicted Model tab. The columns with the same names are automatically selected. You have to manually add the connection for those that do not match. So to do this, you go to the Modify Connection. This is a menu choice that's available when you right-click on one of the related lines or in that area where the relationships are shown visually. The bike buyer column will have the unknown column selected for its relationship, and we have to select this. Lastly, we want to analyze and run this model. The design prediction grid on the bottom of this window is where we specify the prediction information. The selected table is where most of the information is given. The first row in the prediction function designation, it's the field column that contains the predict probability function. We give it an alias like predict bike buyer. The last column needs to be the predicted column bike buyer, which is linked. You can do this by dragging and dropping the mining model from the list above. The predict column will be from the model in the source, DT bike buyer, and the predict columns from the model. Bike buyer is the only one in this model, and there could be more than one. We also need 1 in the criteria argument column, so we are predicting the bike buyer equals 1 and not 0, and 1 for bought and 0 for not bought. These next rows contain the key perspective key or the model customer key, which we change in the alias column. The other columns are selected for output, and in the top left, the results output for the model to execute against the query model. The display output can be saved to a table in the current database connection or to a new connection. Now let's look at a demonstration on how to predict based on a model previously created. We'll launch the SQL Server Data Tools and open up our previous data mining project. Once it's open, we're going to open up the mining model and go to the Mining Model Prediction tab. Here we have two windows, one for the mining model and the other for the selected input table. We'll click on the Select Case table and select Prospective Buyer Table. It'll match up some columns that have similar names, but we have to add some relationships if that's the case. For instance, our unknown column is going to be related to our bike buyer. We can drag and drop that or right-click in the area between them and go to Modify Connections. Here we're able to pick those particular related values. Also, our age is going to come from a calculated age. Here you see age calculated, which is in the data source view. If we go to the data source view and right click on prospective buyer, we can see we can add a new name calculation. Down on the bottom of the list, you see the little icon to indicate a calculated column. And here we can edit it and see that we're looking at the date difference in year from the date of birth to today's current date. We'll close our data source view and come back to our mining model prediction. Next, we're going to have to pick some fields that will be the prediction part of this query. Here, we're going to look at the bottom part of the screen and the grid that lets us select this type of criteria. First, for our source, we're going to go to the mining prediction function, and we're going to select the predict probability function. Here we're going to say this is a bike buyer, and in the criteria argument we need to drag the bike buyer to that particular area. Next, we need the actual column that's going to predict from the model, and that's bike buyer. There's only one predicted column in this model, so under field, that's all we have to select. Last, we have to provide a value equals 1, which means the person bought the bike. Next, we can go to the prospective buyer table and select particular columns. One we definitely need is the customer key, which is what we key off of in our model. The other information is going to be data that we want displayed from our buyer perspective table that displays what the user wants. For instance, we want first name, last name, maybe that computed age, which is probably at the end of this list. And then we also might want the address where this particular person lives for the mailing options, or in the case of this time of the century, we probably just want email address. So now we have the model set up and a query. Behind all this is a DMX query, which is the data mining expression language. We have a visual user interface in order to view this. Now, in order to process this particular prediction, we'll go in the upper left to the switch to, and we'll change it from design to actual results. And here we get the results of the prediction. That was fairly quick to compare that table to the model and get a percentage. Here we'll click the Save button and we'll give it a new name. And this is actually going to go to the data source view we've created and add it to our data source view. We'll click Save, and if we go to the data source view, now we can actually view that particular table and its prediction. The end user now has a table that he can either sort or display in a different way inside of Excel or any other tool. In here we can actually sort by that particular column to see the predictability of, say, a 50-year-old person and their data related in the prospective bike buyer table. This is able to be exported. You can select all and copy them and put it in whatever tool that the end user wants. I'm going to minimize this for now and go to our SQL Server Management Studio and show you that you don't need to just be in SQL Server Data Tools in order to preview this information. All that particular stuff that we just saw can actually be used right inside of Management Studio. And here we'll have to get to a particular one and click Browse or Process, or even look at a lift chart. We can process the data, or we can actually browse it, and it runs that same mining legend along with the viewer we saw earlier. So the end user can use SQL Server Management Studio with the proper permissions to preview the same viewers that you see in SQL Server Data Tools.